Our next type of reaction that we're going to be looking at is an acid-base reaction. And we're going to have a whole unit on this later in this class. And so for now, the type of acid-base reaction we're going to look at is an acid-base neutralization. This will just serve as an introduction to acids and bases. Acids and bases are hugely important in chemistry and especially in biology because they have a massive impact on things like proteins and enzymes. And so we want to understand how these are able to interact in a solution. And so let's first define these. What is an acid and what is a base? Well, an acid is going to be a proton donator. And a base is going to be a proton acceptor. Now, what do I mean by proton here? Well, let's consider the hydrogen cation. This is going to be the star of the show when we have acids and bases. A hydrogen cation, well, what is that really going to be? If we remember the entry of hydrogen on the periodic table, it has an atomic number of 1 with an atomic mass of 1. So if its atomic number is 1, how many protons would it have? Well, it would have 1. And if its atomic mass is 1, how many neutrons would it have? Well, I take that 1, I subtract my number of protons, so 1 minus 1, that's 0. No neutrons. How many electrons would it have? Well, it would start with 1, but then when it ionizes to become a cation, that goes away. So really, this hydrogen cation is just a lonely little proton. And if we remember from ionic and atomic radius, most of this atom is empty space. This atom really is normally, even normally, going to have a huge empty bit of space here between the nucleus and the electrons. And so most things don't get that close to that proton. And so the fact that this hydrogen cation is just a proton without any electrons means that another atom like fluorine could get right up next to that and absorb it. So that hydrogen cation is going to be hugely reactive. Okay, and that's going to be the star of the show. So because it's just that little proton, we just call it a proton. And so when we say proton donator or proton acceptor, that's what we're talking about. Now, when we look at bases, the main base we're going to look at now is going to be the hydroxide anion. So if I see something like sodium hydroxide or lithium hydroxide, those are going to be my bases. We'll look at different types of bases later on, things like ammonia, but for now, we're just going to use the hydroxide anion to represent a base. So if you see the hydroxide anion, that would be a base. Now, what about an acid? Well, this is going to be a little more complex because an acid is going to be that hydrogen cation bonded with some kind of anion. And so we need to be able to name these in a specific way to identify it as an acid. And unfortunately, we have a very long history of naming acids that has made our modern conventions a little complex. So we're going to have to go through and learn how to name these acids. So let's start with some examples here. I'm going to write up HCl, Hno2, and HClO4. My HCl, I'm going to be able to identify these as acids because they have an anion here. This anion right here, see that? These are all anions, and they are bonded to a hydrogen cation. So we could call this hydrogen cation my acid indicator. So I know that this is an acid because it has a hydrogen cation. So then, as far as naming this goes, I'm actually going to focus on the anion. So I'm going to start with this one right here. This is HCl. So this is the chloride anion. And so chloride, what I'm going to do is I'm going to take this suffix. I'm going to use that suffix to identify my naming convention. So if my anion ends in "ide," right there, so I'm going to write in chloride, then the acid is named hydrochloric acid. So chlor, there we go. So this HCl is hydrochloric acid. How about this next one? HNO2. NO2 is nitrite. And so if I put this in here, it's going to be nitrite. There we go. That's my suffix right there. Then I'm just going to put this in my blank here, and it's nitrous acid. There we go. That's it. Simple as can be. ClO4 here, this is perchlorate. So my 8 here, that's my suffix. So I'm going to take this, and I'm going to go perchlorate. There we go. And then I'm just going to put that same thing in the blank spot. Perchloric acid. So that's how I'm going to name these acids, okay? And what I really want to do is I want to go to my page that has all of my anions listed. And I'm going to use this to help me identify those acids. So I don't need to do anything with that hydrogen cation. That just tells me that it's an acid, and then I'm just going to follow the regular acid naming convention. So let's try one more. Let's grab what would, if I used cyanide here, what would cyanide look like? Well, cyanide, that would have that H, be an HCN, well, and that's going to be cyanide. So cyanide. And it's going to have the ide, so I'm going to say cyan. So that's going to be hydrocyanic acid. There we go. That's it. That's the name of HCN, hydrocyanic acid. So that's not too tough, right? So there's two exceptions to this. There's two compounds that get named in a weird way, and that's going to be sulfur and phosphorus. So let's consider H2SO4, right? H2 because H plus is just 1 plus and SO4 is a 2 minus, right? So we still need to balance that out, but that doesn't affect our name. So the SO4, this is sulfate, right? Let's bring this down here. This is sulfate. And so we would expect to go sulfate, we would say sulfic acid. But for sulfurous compounds, we keep that UR on the end of it. So instead of saying sulfic acid, we say sulfuric acid. And that's going to be the same way. If I used sulfite, I would say sulfurous acid. Okay? And phosphorus is going to have a similar convention. So let's look at that. If I've got H3PO4, H3PO4, well, that's phosphate, right? Would that be phosphic acid? No, in the same way that we take sulfur and make it sulfuric acid, I'm going to take phosphate and make it phosphoric acid. Okay? So we'll just have to remember that. For sulfur, I keep that UR on it, and this is for all sulfur-related acids. Sulfate, sulfite, sulfide. Phosphoric acid, and phosphorus is going to be the same way. I'm going to keep that OR on it when I make my acid name. So phosphate becomes phosphoric acid, phosphite would become phosphorus acid, and phosphide would become hydrophosphoric acid. Okay? So that's everything we need to know about acid nomenclature.